Hello, welcome to Exam Plug, and today I'm going to go through the Bmat Section 2 from November 2009. This is the Scientific Knowledge and Applications paper of the Bmat, and it is non-calculator. Just a quick mention before I start, it'd be great if you could like the video, subscribe to the channel, and turn on post notifications. It will help me out massively. Now, without further ado, let's get straight into the paper. Question 1. Individual A in the family pedigree below is homozygous dominant and individual B is homozygous recessive for a particular feature. What is the percentage probability that individual F is homozygous recessive if I, E is homozygous recessive, II, E is heterozygous? So this question is on Mendelian genetics essentially. We know that we have two copies of each gene, one from our mother and one from our father. Expression of a trait is dependent if the trait is dominant or recessive. Dominant genes only need one copy to be expressed, and recessive genes require both copies to be expressed. We could use this definition and information to help us with this question. We know individual A has a genotype of big Q, and individual B has a genotype of little q. Using this information, we can draw a Punnett square to determine the possible genotypes of their offspring. So let's get straight into that. Big Q, little q. And what are the possibilities that we could get? Big Q, little q, big Q, little q, big Q, little q, and big Q, little q. Therefore, there's a 100% chance that the genotype of the offspring is heterozygous, or in other words, big Q, little q. Now, if E is heterozygous recessive, the offspring genotypes is 50% for big Q, little q, and 50% for little q. If E is heterozygous, the offspring genotype probability is 25% big Q, 50% big Q, and 25% little q. Using this information, we could determine that C is the correct answer. And that is question 1 completed. Question number 2. Which of the following could take part in an addition polymerization? 1. CHI3, 2. C24H48, 3. CH3H7Br, 4. C4H6Cl2, 5. C8H12Cl4. This question requires basic GCSE understanding of organic chemistry. So addition polymers are formed from alkenes, or in this case, alkenes that have halogens attached to them. And the formula of an alkene, the general formula anyways, is CnH2n. And using this information, we could straight away figure out which of these molecules can undergo addition polymerization. So looking at number one cannot undergo addition polymerization because it's an haloalkane. So no. Number 2, that can because that's an alkene. Perfect. 3, that is an haloalkane, so that cannot undergo addition polymerization, so that's cancelled. 4 can undergo addition polymerization because it's an alkene that has halogen functional groups attached to it. 5 can also undergo addition polymerization. You could figure this out through deduction. Also, it's an alkene with halogen groups attached to it instead of some hydrogens. So the answer for this question is E, and that's question 2 completed. Question number 3. Shortly after opening her parachute, a freefall parachutist of a mass 60 kilograms experiences the forces shown in the diagram. Drag/air resistance is equal to 900 newtons and the weight is 600 newtons. Which line in the table gives the size and direction of the acceleration of the parachutist at this instance? So, this question requires us to work out acceleration from force and mass. So we're going to use the equation F equals ma. And what is the force over here? The force is the net force, the overall force being experienced by this parachutist. So that would be 900 minus 600, which is equal to 300. So we have an overall net force of 300 newtons. And it says the parachutist's mass is 60 kilos, and A is what we're going to solve for, the acceleration. So A is equal to 300 over 60, which is equal to 5. Now, the direction of the acceleration, that's very straightforward. Which direction is the force greatest in? The 900 or the 600? It's the 900. Therefore, the acceleration is upwards. Thus, the answer is C. That is question 3 completed. Question number 4. A bag contains X red balls, Y blue balls, and Z yellow balls. One ball at random is taken out and replaced. A second ball at random is taken out and replaced. If the balls are identical in all respects except for color and are mixed well, what is the probability that the first ball was red and the second blue? So, step 1 is work out the total number of balls in this bag. That would be X plus Y plus Z. So that is your total. Now, step number 2 is to work out the probability that the first ball being taken out is red. So, what is the number of red balls? X. So therefore, the probability that a red ball was taken out first is X over X plus Y plus Z. So that's the first ball. Now for the second ball, we have the same denominator because the balls are being replaced each time. So X plus Y plus Z. And how many blue balls are there? There are Y number of blue balls. There's that. So, now it's asking us to work out the probability that the first ball was red and the second ball was blue. So what we're going to do is multiply the first and second probabilities together, which gives us a probability of X, Y over X plus Y plus Z squared. And therefore the answer is C. And that is question number 4 completed. Question number 5. Which one of the following statements is true about the members of a clone? Statement A. Members of a clone will always show identical features at maturity. This is false because at maturity there will be environmental factors that could lead to the clone showing different features and traits. For example, skin color. One twin that's genetically identical to the other may be tanned and the other one may not be tanned. Statement B. Multiple births, such as twins, are always members of a clone. This is false. This is because twins can be non-identical. They could have come from 2 different eggs and 2 different sperm. So B is incorrect. C. They are produced only during genetic engineering. This is also false because some twins are identical and this occurs naturally. So C is incorrect. D. They are the result of a mutation. This is standout false. For something to be a clone, they have to be identical, and a mutation would mean that there's a change in the DNA, which would cause one of the clones to be not identical to the other. So D is incorrect. And finally, E. They contain identical DNA. This is correct, because the essential feature of clones is that they have the same identical DNA. That is question 5 completed. Question number 6. Which one of the following covalent substances could exist as a giant structure? For this question, you have to draw upon your GCSE and maybe your A-level knowledge. You would have come across 3 covalent giant structures, and they are diamond, silicon dioxide, and silicon carbide. Diamond and silicon carbide are not present in this list, but silicon dioxide is. So therefore, the answer is B. That is question 6 completed. Question number 7. Which of the following is a correct unit of potential difference, otherwise known as voltage? For this question, you have to think very deeply about your physics equations that you learned at GCSE. And the two that stand out to me in this moment in time is V equals IR and W equals IV. So, of course, V equals IR does not come up in any of these options here. So, eliminate that. Now, W equals IV. If we rearrange this to make V the subject, W over I, we should be able to find the correct answer in this list. And we can, E, because W is watts and I is amps, current. So therefore, the answer is E, and that's question 7 completed. Question number 8. A cube has unit length sides. What is the length of a line joining a vertex to the midpoint of one of the opposite faces? The dashed line in the diagram below. So how would I solve this? First, I would want to work out what the distance over here is. So I know this is 1 centimeter and I know this is 1 centimeter, and it's a right angle triangle being formed. And to work out this distance over here, I'm going to use Pythagoras' theorem, which is a squared plus b squared is equal to c squared. So a squared is 1 squared plus b squared is 1 squared is equal to c squared, which is 2. And to work out c, we have to square root 2. So we now know that this length is equal to root 2. Now, step number 2. I now want to work out the length of this distance. Step number 2. I now want to work out this distance. How do I do that? Well, I know what this distance is because it's half of this distance. And I know what this distance is, it's 1. So I'm going to draw another triangle where it has a side length of 1 and a side length of root 2 over 2. And I'm going to use Pythagoras' theorem to work out what this distance is over here. So 1 squared plus root 2 over 2 all squared is equal to 3 over 2. And that's c squared. And I want to work out what c is. C would be 3 over 2 square rooted. And what do you know? The answer is B. And that is question 8 completed. Question number 9. The data below considers the risk of having a cancer in the neck region due to drinking alcohol and one genetic factor. Presence of a mutant allele for the CYP1A1 gene. A risk value of 1 is the mean average risk in the human population. This table here. Using only the data from the table, which of the following tentative conclusions about risk of having cancer of the neck is not correct? Option 1. Overall, the presence of at least one mutant allele increases the risk. This option is true because both heavy and light drinkers have a notable increase in the risk value with the presence of one mutant allele compared to no mutant alleles. So option 1 can be removed. B. Overall, there is a positive correlation between the risk and alcohol intake. This is also true because at all numbers of mutant alleles, heavy drinkers show an increased risk compared with light drinkers. So we can eliminate B. C. Heavy drinking is the main factor in increasing the risk. This is correct because the difference in risk between light and heavy drinkers is much larger than between individuals within the same drinking category, however, with different numbers of mutant alleles. Option D. The presence of at least one mutant allele is the main factor for increasing risk. This option is not correct because heavy drinking does increase the risk more than having one mutant allele and is therefore the main factor. So the answer is D. And for principle's sake, I'll go through E. The presence of two mutant alleles increases the risk more for heavy drinkers than with light drinkers. This is correct because having two mutant alleles increases the heavy drinker's risk by 2, compared with an increase of 0.8 with light drinkers. And that is question 9 completed. Question number 10. 2 grams of carbon compound is burnt in excess oxygen. 4.77 grams of carbon dioxide is produced. What percentage to the nearest 1% of carbon is in the original compound? First things first, we need to write an equation of C plus O2 goes to CO2. The reason for this is because we can see a rough ratio of carbon dioxide to carbon. Next step, we need to figure out the number of moles of carbon dioxide. So, what is the MR of CO2? The MR of CO2 is 12 plus 16 plus 16, which is equal to 44. Using this information, we could calculate the moles of CO2, which is mass over MR. So 4.77 over 44 is equal to the moles of CO2. And using some long division, I won't demonstrate it here, the answer comes to 0.1084. Knowing that there is a 1-to-1 ratio between carbon dioxide and to carbon, we also know that there is 0.184 moles of this carbon compound. Now, using this 0.1084 mole value, we could times this by the MR of carbon. So we'll do 0.1084 times by 12, which is equal to 1.3. Now we need to work out the percentage of carbon in the original compound, so that's 1.3 over 4.77 times 100, which is equal to about 65%. So the answer to question 10 is E, and that's question 10 completed. Question number 11. It is known that a radioactive source emits a single type of radiation. Detectors are placed in 2 positions shown. The graph shows how the readings change over time. Which type of radiation does the source emit, and what is its half-life? So, this question is looking at our understanding of different types of radiation and what half-life is. So, what I'm first going to do is determine what type of radiation is being emitted by this source. So, I'm going to first look at the graph. Detector 1 has a curve and detector 2 is a straight line. So now I'm going to use my knowledge of different types of radiation to determine what is being emitted by the source. So alpha radiation can only travel a few centimeters in air, beta radiation can travel tens of centimeters, and gamma radiation can travel many meters. Looking at detector 2, which is 1 meter away, the count rate is pretty flat. It just stays consistently at 20. So therefore, the source is not emitting gamma radiation, because if gamma radiation was present, we would have some form of curve being shown on the graph. Now we're left with alpha and beta radiation. We know it cannot be alpha radiation because the detector 1 is 30 centimeters away from the source. Alpha radiation can only travel a few centimeters, but beta radiation can travel tens of centimeters. So therefore, the source is emitting beta radiation. Now, we're going to look at the half-life of this beta radiation. Now, what is the definition of half-life? The half-life is the time taken for the radioactivity of a specific isotope to fall by half its original value. Okay, now I'm going to determine what the half-life is. But what is half-life? The half-life is the time taken for the radioactivity of a specific isotope to fall by half its original value. So, what is the original value for this beta radiation? It's going to be 220 minus 20, which is 200. Now, what is half of 200? Half of 200 is 100. So we're going to minus 220 from 100. And that will give us the count rate at when it's half-life. So 120. And then where it intersects with detector 1, 120 counts. We're going to go down to the x-axis. And where is that roughly? That is roughly at 2.4, and therefore the answer is C, 2.4. The symbol defines a mathematical binary operation such that y symbol x is equal to y to the power of x over x for all positive integers. What is the value of open bracket 2, symbol 3, close bracket, symbol 2? So, this is a straightforward mathematical situation in which you basically follow Bmat and do the operation twice. So, if we let y equal 2 and x equal 3, we are going to get 2 to the power of 3 over 3, which is equal to 8 over 3. So, this brackets area is 8 over 3. Now, we are going to repeat this binary operation, but y is going to equal 8 over 3, and x is going to equal 2. 8 over 3 to the power of 2 over 2 is equal to 64 over 9 divided by 2, which is equal to 32 over 9. And the answer is therefore C. That's question 12 completed. Question number 13. Which one of the following movements will be severely and immediately disrupted if the oxygen concentration in the blood becomes very low? Immediately from this question, you should be thinking about active transport, but it's looking at oxygen concentration. And what requires oxygen? Respiration, active transport. So, knowing this information, let's answer the question. So A, carbon dioxide from the blood into the alveoli. This occurs through diffusion and has no relevance to the oxygen concentration. in the blood, so A is incorrect. B. Glucose from the lumen of the intestine into the villi. This is the answer to the question because active transport is used to transfer the glucose from the lumen of the intestine into the villi. So B is the correct answer to the question, but I'll keep on going through all the options. C. Oxygen from the alveoli into the blood. Yet again, this occurs through diffusion and it's a passive process, so that is incorrect. D. Urea from the blood plasma into the nephron. This occurs through ultrafiltration, which doesn't require oxygen, so D is eliminated. Option E. Water from blood plasma into muscle cells. That occurs through osmosis, so that is incorrect. And that's a bit of a trick question because it has muscle cells in it, and people are going to be thinking, muscle cells, they respire a lot, so that has to be answered. No. Option F. Water from blood plasma into the nephron. That is also incorrect. That occurs through passive processes. So your answer is B. And that is question 13 completed. The order of reactivity of 4 elements is J is greater than M, which is greater than Q, which is greater than T, i.e. J is the most reactive and T is the least reactive. A series of reactions are given below. Which of the 3 reactions could take place? So this is a chemistry-based question about displacement, essentially, and should be relatively straightforward. So option 1, MCl2 plus T goes to TCl2 plus M. Can that reaction occur? No, it cannot, because T cannot displace M because it's less reactive. So 1 is eliminated. Can reaction 2 occur? MSO4 plus J goes to JSO4 plus M. That can occur because J is the most reactive element in this list of elements that we've been given, elements of form. So therefore, 2 can occur. 3. TO plus Q goes to QO plus T. This can occur because Q is more reactive than T. T is the most unreactive element in our list. So 3 can occur. 4. QO plus J goes to JO plus Q. 4 can occur because J is more reactive than Q. 5. JSO4 plus T goes to TSO4 plus J. This cannot occur because T is less reactive than J. 6. MO plus Q goes to QO plus M. This cannot occur because M is more reactive than Q. Therefore, the answer to this question is B. And that's question 14 completed. Question number 15. The graph represents the motion of a vehicle during part of a journey. What is the best estimate of the distance travelled during the part of the journey shown? So, we need to use the equation speed is equal to distance over time in order to work out what the distance is. So therefore, we need to rearrange this equation, which will give distance is equal to speed times time. Armed with this information, we can now split the graph up into different sections, so it'll be easier to work out the area of the graph, the distance essentially. So I'm decided to split my graph up into 4 areas. So I've got area 1, I've got area 2, area 3, and area 4. Area 1 and 3 are trapeziums. Area 2 is a rectangle. Area 4 is a triangle. And now I'm going to work out the areas, the distances for each of these sections. So, area 1 is equal to 15 plus 20 over 2 times by 60. The reason why I say 60 is because the speed is given in meters per second, but the x-axis is in minutes. So we have to convert the x-axis into seconds. And that gives us 1050. Area 2 is 20 times by 180, which is equal to 3600. Area 3 is equal to 20 plus 10 over 2 times by 60, which is equal to 900. And area 4 is equal to 10 times 180 over 2, which is equal to 900. Now I want to have the sum of all of these areas to get the total area. So A total is equal to 1050 plus 3600 plus 900 plus 900, which is equal to 6.45. And wait a minute, you're about to think, oh, the answer is E. It isn't, because if you remember, in area 4, we made a triangle. But if you look, the lines don't match up. We actually overestimated the area 4, so we need to make a slight reduction to our final answer. So therefore, the answer is going to be D. And that is question 15 completed. Question number 16. Evaluate this equation. So this is relatively straightforward maths. There's not really much explaining to do, so I'm just going to write everything down and give my final answer. So that is equal to... What you just need to remember here is following Bmat, really, and you should be fine. And there you have the answer. The answer is F, and that's question 16 completed. Question number 17. Which of the 4 statements below about natural selection are correct? 1. Competition occurs between individuals of the same species. 2. Competition occurs between individuals of different species. 3. Selection can lead to evolution. 4. Selection can lead to extinction. I'm going to straight away say the answer because you guys should know the answer from GCSE biology. And the answer is F. The reason for this is because natural selection applies to all of them. Number 1, competition occurs between individuals of the same species. This is intra-species competition that occurs quite often. Natural selection that occurs in the same population. 2, competition occurs between individuals of different species. That's interspecies competition. And competition. 3, selection can lead to evolution. That's a given. Natural selection, the whole point of it is evolution. And statement number 4, selection can lead to extinction. Well, if you don't have advantageous alleles and your species or the individual themselves is undergoing evolution, they won't survive, and their species won't survive as a result because they don't have the advantageous alleles to survive or the characteristics to survive, and they go extinct. Therefore, the answer is F, and that's question number 17 completed. The equation for the preparation of nitrogen monoxide is the equation below. What's the value of B? There are two ways that you could do this. I think one way makes more sense than the other due to the actual exam itself. You could do trial and error, which I would recommend, and I would leave this question for right till the end because it's quite time consuming. And the other option is to make the whole equation into a bunch of simultaneous equations and then solve it. So, if you do it via simultaneous equations, you can make the hydrogen equal B, which is equal to 2C. You can make the nitrogen B, which is equal to 2A plus 2. You can make the oxygen into 3B, which is equal to 6A plus C plus 2. And you can rearrange 2 and then substitute it into, well, when I mean 2, 1, 2, 3, you can rearrange 2 and then substitute it into equation number 3, and then that will give you C is equal to 4. You could substitute C is equal to 4 into equation number 1, so therefore B is equal to 8. The answer is D, and that's question number 18 completed. But I would like to say that this is quite a lengthy process to do, and I would not recommend doing simultaneous equations unless you have bags of time. I would recommend saving this question for right till the end and then doing it then, because you could pick up a lot more easier marks instead of just trying to solve one question. Question number 19. An object of mass 5 kilograms falls from rest and hits the ground at a speed of 20 meters per second. Air resistance is negligible. From what height has the object fallen? Take G to be 10 meters per second. So, straight away you should be thinking, this is a physics question and I'm going to have to use my physics formulas that I learned in GCSE physics. And this question is looking at gravitational potential energy and kinetic energy. How do I know this? Because it gives me G, it gives me the weight, and it's asking for H. So gravitational potential energy formula is lurking about here. And in regards to kinetic energy, it gives us the mass and it gives us the velocity, which is needed for kinetic energy. So let's write these formulas out. So Ke equals a half mv squared, and gravitational potential energy equals mg delta h. They should equal each other because air resistance is negligible. 0.5 mv squared is equal to mg delta h, and we want to isolate delta h, and we're going to simplify as we go along. That comes to v squared over 2g. We were able to cancel out mass because there we go. Now we're going to substitute the actual values in. So velocity squared is 20 squared over 20, which is equal to 400 over 20, which is equal to 20. So the answer to this question is B, and that's question 19 completed. Question 20. A solid sphere of radius r fits inside a hollow cylinder. The cylinder has the same internal diameter and length as the diameter of the sphere. The volume of a sphere is 4/3 pi r cubed, where the radius is equal to r. What fraction of the space inside the cylinder is taken up by the sphere? So, we first need to write down what the volume of a cylinder is. Fortunately, the radius is equal to r, so we don't need to manipulate the formula too much. So, it's going to be pi r squared h. And we already know what h is because it says the cylinder has the same internal diameter and length as the diameter of the sphere. So the diameter of the sphere is 2r. So I'm going to write 2r here and substitute it back in. So 2r substitute back in is pi r cubed times 2 is equal to 2 pi r cubed. Now, we are going to divide the volume of the sphere by the volume of the cylinder. So we're going to do 4 over 3 pi r cubed divided by 2 pi r cubed is equal to, now I'm going to be a bit lazy here and just modify my working out, but essentially we're going to divide, so we're going to put that 1 over. We can straight away cancel the pi's, pi, cancel the 2 here, 1, 4 divided by 2 is 1, and r cubed cancel out each other, and then you're just left with 2 over 3, and therefore the answer is D. That's question 20 completed. Question number 21. The diagram shows a section through an alveolus. Gas diffused through the alveolar and capillary walls. Which row explains why gaseous exchange occurs in the alveolus? So we have oxygen in alveolus, oxygen in capillary, carbon dioxide in alveolus, and carbon dioxide in capillary, and this is all in relation to concentration. So this is testing our knowledge of biology and gas exchange. So the concentration of oxygen in the alveolus, it's going to be high. The reason for this is because the oxygen needs to be in a high concentration so it could diffuse into the blood, because diffusion occurs from high concentration to low concentration. So we could eliminate all of the lows. So we could eliminate B, we could eliminate E, we could eliminate F. Now moving on, oxygen in the capillary. This is the oxygen concentration in the blood of the capillary. This is going to have a low concentration of oxygen, but a very high concentration of CO2, because all of the oxygen has been used up by the cells in respiration, and the product of respiration is energy and CO2. So I've already answered, therefore, the concentration of oxygen in the capillary and the carbon dioxide in the capillary as well. So let's quickly do that. So oxygen, anything with high we could cancel, and carbon dioxide in capillary is going to be high. So therefore the answer is going to be D. And that is question 21 completed. Question number 22. At room temperature, a reaction is very fast if no bonds are broken while it takes place, and is slow if bonds have to be broken. And reaction 1, H2 plus I2 goes to 2HI. Reaction 2, Ag plus Cl minus goes to AgCl. 3, CH3 plus CH3 goes to C2H6. 4, OH minus plus CH3 Br goes to CH3OH plus Br minus. Which of the following are the two fastest reactions? So this is using your knowledge of chemistry, in particular higher level GCSE chemistry and a bit of AS chemistry. So, which of these reactions are going to require bond breaking? Definitely one, because you have to break the hydrogen-hydrogen bond and the iodine-iodine bond to allow the hydrogen and the iodine atoms to react. And 4, you have to break the carbon-bromine bond in order to allow the hydroxide ion to react with the carbon. So therefore, 1 and 4 are incorrect, and you're left with 2 and 3 as your answer. 2 is correct because it's just 2 ions that just need to react. There's no bond breaking required there. And reaction 3, they're 2 radicals actually. They're 2 methyl radicals. And they'll react together quite readily as well. So the answer is D, and that's question number 22 completed. Question number 23. A train consists of a powered engine pulling 2 unpowered carriages. The engine has a mass of 20,000 kilos, and each carriage has a mass of 5,000 kilos. When the engine accelerates from rest, it develops a thrust driving force of 15,000 newtons as shown. Ignoring resistive forces, what is the tension, T, in the coupling between carriages 1 and 2? So first, what you need to do is treat the system as a whole, and then we'll break it down. So, step 1 is treating the system as a whole. Step 2 is finding out the mass of the overall system. So, 20,000 plus 2, open bracket, 5,000 is equal to 30,000. And now we have the mass. Now using the formula F equals ma, we could work out the overall acceleration of this train. And how we're going to do this? By rearranging this formula to give A is equal to force over mass. So let's do that. So 15,000 over 30,000 is equal to 0.5 meters per second squared. Now we need to look at the forces. The only force acting on carriage 2 is the tension in the coupling between 1 and 2. Therefore, the force required for carriage 2 to accelerate at 0.5 meters per second squared will be given by Newton's second law, F equals ma. So, the weight of the carriage is 5,000 times by 0.5 is equal to 2,500. And therefore, the answer is A. That's question number 23 completed. Question number 24. The equation gives y in terms of x. Y is equal to 5, open brackets, x over 2 minus 3, close bracket, squared, minus 10. Rearrange the equation to give an expression of x in terms of y. This, quite frankly, is a very straightforward rearranging of the equation, but I'll do it anyways. So I'm going to add 10 on both sides, so y plus 10 is equal to 5x over 2 minus 3 squared. Then I'm going to divide both sides by 5, so y plus 10 over 5 is equal to x over 2 minus 3 squared. Now I'm going to square root both sides, so when you square root something, you could have a positive and negative answer, so plus or minus square root of y plus 10 over 5 is equal to x over 2 minus 3. Then I'm going to add 3 on both sides. 3 plus or minus square root of y plus 10 over 5 is equal to x over 2. And then I'm going to multiply both sides by 2. That goes 2 6 plus or minus 2 square root of y plus 10 over 5 is equal to x, and that means the answer is A. That is question 24 completed. Question number 25. The following 5 statements relate to homeostasis. Statement 1, insulin helps to control the water content of the body. Statement 2, homeostasis depends only on hormones. 3, the pancreas helps to control the glucose content of the blood. 4, both the nervous and hormonal systems are involved in homeostasis. 5, the skin is used to help control the body's temperature. So, statement number 1, insulin helps to control the water content of the body. This is straight up wrong. Insulin is used to control glucose content. So, 1 is wrong. 2, homeostasis depends only on hormones. This is incorrect. Homeostasis requires the hormonal and nervous systems, so therefore it requires electrical impulses as well, which is involved in the nervous system. For example, shivering is controlled by the nervous system, not by the hormonal system, and shivering is very important in homeostasis. So 2 is incorrect. 3. The pancreas helps to control glucose content of the blood. This is true because in the pancreas we have beta cells, and they have receptors on them that can stimulate insulin production. So 3 is correct. 4. Both the nervous and hormonal systems are involved in homeostasis. I've mentioned that with statement 2, and that is correct. 5. The skin is used to help control body temperature. That is correct. A prime example being sweating. You sweat onto the skin. So 5 is correct. Therefore, the correct answer is F, and that is question number 25 completed. Question number 26. Naturally occurring chlorine is a mixture of 2 isotopes with mass number 35 and 37. The isotope with mass number 35 is 3 times as common as the isotope with mass number 37. Naturally occurring bromine is a mixture of 2 isotopes with mass number 79 and 81. They are present in equal amounts. What fraction of the naturally occurring compound CH2BrCl has a relative molecular mass of 128? So, step 1 is to work out what the weight of the BrCl is in this naturally occurring compound. So we know the total is 128 minus the weight of carbon, which is 12, minus 2 hydrogens, which is 2, which is equal to 114. Now we need to determine which isotopes of chlorine and which isotopes of bromine equal 144 in their combined atomic weight. And that would be Cl35 and Br79. And now we need to work out the probabilities of each of them occurring naturally. Now we need to work out the probabilities of each of them. So, Cl35, the probability is 3/4, and Br79, the probability is 1/2. Now we need to multiply these two probabilities together, so 3/4 times by 1/2 is equal to 3/8. Therefore, C is the correct answer, and question number 26 has been completed. Question number 27. The first graph shows a variation of the displacement of particles with distance along a wave at a particular instant in time. The second graph shows a variation with time of the displacement of a particular particle in this wave. What's the speed of this wave? Straight away you should be thinking this is a physics question. I should be thinking about the equations that I learned in GCSE physics. And the one that stands out straight away is velocity is equal to frequency times by wavelength. Now we have wavelength in graph 1, We do not know what the frequency is, but we need to work out what the velocity is. We can work out what the frequency is because the frequency is equal to 1 over the period. And the period is the time taken for a wave to complete one full oscillation. And we can work this out from the second graph. So the second graph, to complete 3 full oscillations, 1, 2, and 3, it takes 0.6 seconds. So to complete one oscillation, it would take 0.2 seconds. Therefore, the frequency would be 1 over 0.2, which is equal to 5. And let's quickly work out the wavelength. There are 2 oscillations here, and it says the distance is 60 meters. We want to work out what one oscillation is. 60 divided by 2 is 30. And now we're just going to substitute these values into the equation over here. So 5 times 30 is equal to 150, and that's our velocity, and the answer is E, and that's the answer to question number 27.